In the previous section, we learned a whole lot about sine and cosine functions, and in this video, we're going to learn about more about other trigonometric functions. So we will learn how to find exact values of the trigonometric functions of secant, cosecant, tangent, and cotangent for angles of pi over 3, pi over 4, and pi over 6. Use reference angles to evaluate the trigonometric functions for secant, tangent, cotangent, and also use properties of even and odd trigonometric functions, recognize and use fundamental identities, and evaluate trigonometric functions with a calculator. So that's what's on the menu for this section. And we're going to start by recalling some basics that we learned previously. So we learned about unit circle. It's a circle centered at 0, 0 with radius 1. And if we look at the point, the terminal side of angle T is forming by crossing the circumference of the circle. If we look at the coordinates of that point x and y, then cosine t will equal to x coordinate at that point, and sine of t equals to the y coordinate of that point. And both this radius and the length of this part of the terminal side is also equals to 1. Let's recall the definition of other the rest of the trigonometric functions of that angle. So the first one is going to be secant. Secant t. For short, we're going to write it like this, secant of t, and secant is 1 divided by cosine of t. So basically 1 divided by x, and of course we cannot divide by 0, so x should not equal to 0. So what this leads us to is the conclusion that secant is not defined where x coordinate equals 0. And when does that happen? At pi over 2, and also 3 pi over 2. So for those angles, secant t is not defined. Now let's talk about cosecant. And cosecant t is abbreviated by CST, CSC, and the definition is 1 divided by sine of t. So basically 1 divided by y. And again, y should not equal to 0. And again, that means that this function is not defined for angles where the y coordinate is 0. So basically you have 0, pi, 2 pi, so forth. And the next function that we want to talk about is tangent t, tangent t, tan t for short. And of t, and tangent t is sine over cosine. So for the unit circle, and actually for any other circle, it's going to be y coordinate divided by x. So it's a proportion of the side, which will stay the same for any size of the triangle, remember? So it does not actually depend on the radius of 1 anymore. And the last function is a cotangent. I'm going to start here. Cotangent and of t. for short is C over T, and that will be cosine T divided by sine T, and so it's X divided by Y. So, and again, the tangent is not defined where X equals 0, just the same as secant. And cotangent is not defined where y equals to 0, just like a cosecant. All right. So here's a summary of what we just said, and it's in your book in section 7.4. I didn't actually bring it into the slides, but you can always find it there, or you could pause here and copy these formulas accurately. And of course, as usual, let's apply what we just learned. So this example says we're given a point of negative square root of 3 over 2. There is a negative there. And 1/2, those are our coordinates, and they're on the unit circle, and they want us to find the sine t, cosine t, tangent t, secant t, cosecant t, and cotangent t. All right, so first let's write, as we know, sine t equals the y coordinate if it is a unit circle, right? If our radius equals 1, and it says that this point is on the unit circle. So we don't have to, otherwise we would have to divide out y by r. But in this instance, we're good to go. So it's 1/2. So the cosine of t, and you could put t in parentheses or not, up to you. Both notations are acceptable. That's just the x coordinate, which is negative square root of 3 over 2. Now, next, we're asked to find the tangent. So the tangent is y divided by x. So that's going to be 1/2 divided by negative root of 3 over 2. And if you recall how we divide fractions, then we basically turn it into multiplication. We keep the first one, switch the division into multiplication, and flip the second one. So negative 2 over root of 3. And we could, move negative either to the numerator or the denominator, your choice. So 2 and 2 cancel out, and what we have left is, let's continue here. So it's 1 over 1 times negative 1 over root of 3. So basically negative 1 over root of 3. But remember that we need to rationalize our denominators always. So we multiply by the root of 3, the top and the bottom. And our final answer is negative root of 3 over 3. So that's for tangent. Let's proceed to secant. And secant is 1 divided by x. So it's 1 over divided by, well, it's gonna look nasty, but basically it's 1 divided by negative root of 3 over 2. And again, how do we divide? Turn it into multiplication, flip the fraction. So that's negative 2 roots of 3. But again, in order to rationalize the denominator, multiply the top and the bottom, but the root of 3, and we get negative 2 roots of 3 divided by 3. The next function that they want us to find, cosecant t is 1 over y. So we have 1 divided by, and y is 1/2. So that turns into 1 times 2 over 1, which is basically 2. The next one is cotangent. So cotangent of t is x over y. So we have negative root of 3 over 2 divided by y is 1/2. So you could, instead of writing it as a fraction, just expand it this way and go to apply the fraction division rule. All right, so this is it. This is how you would do this problem. And let's just highlight. So sine t is 1/2. Cosine t is negative root of 3 over 2. Tangent t is negative root of 3 over 3. Then secant t is negative 2 roots of 3 over 3. Cosecant is just 2, and cotangent t is negative root of 3. This is what we got. Now I want you to try this by yourself. And here's the problem. Again, we have a unit circle and a point on the unit circle. This is square root of 2 over 2 and a negative root of 2 over 2. And again, let's find all 6 trigonometric functions of this angle. Pause here and work on the problem.